this will send a signal. What signal send? X of signal will be sent. This will be sent to the transmitter. So transmitter stops transmitting. Correct. Now the CPU2 reads the data. When all the data is read, then it will send XON character. It will send XON character. Please send it. So this is how the software, this one. Transmitter will receive the transmission if I receive the XON character from the receiver. Please note that who is going to send this? First, the transmitter send the data and it fills the buffer. If a buffer is full, X of character will be sent to the transmitter. So this stops transmission. Once the buffer is cleared, again it will send XON. So please send. XON means again send the data. By sending XON X of, the receiver control the data transmission. This is called as software handshaking. You got it? Any doubts?
No, sir. You can proceed.
Okay, fine. Now already we talked about this. You know about it, how it works. And already we talked about two-year communication advanced, already taken notes. I'm not going to repeat this. I stopped here. Serial peripheral interface, which is called as synchronous communication bus. In SPI bus is a serial communication protocol originally developed by Motorola. It was developed by Motorola for communicating with two controllers, two microprocessor or microcontrollers. MUSI or MIP. Okay, and it can be used for other devices, peripheral, or any other device also. The SPI enables communication between any two electronic devices that support clocked serial streams. Okay, as I told yesterday, in synchronous communication, you have four lines, four wires. One wire is called as SCK clock, SCK wire. Second one is MOSI. The third is the MISO. Fourth one is SS. This is the standard nomenclature, right? Use. So you can see the device which send the data is called master device. The device which receives this data is called slave device, right? One is transmitting, other one is called slave. So both are connected using four wires. These are signal name. Okay, SCK is nothing but a clock from the master. Whenever it transmit data, it will transmit this clock also through this wire. Now the data is transmitted using MISO. You can see the word MISO. It is short form of master out, slave in. Master out means master is transmitting data. This is my data. What is the data? Correct? 11001010. 8-bit data I am transmitting. Okay, I'm 8-bit data is I'm transmitting. So so this is master. Who is transmitting? Master. Master output, slave input. You cannot enter. It is like a transmit receive signal in RS-232, similar to that. Okay. Then next one is called as MISO. That means master in, clock, slave out. So that means here data is going from master to slave. Okay. When the master wanted to transmit data, it will transmit through this wire only. When slave wanted to give any reply, it will transmit not through this, it will use the MISO, this wire, which is nothing but master is in. That means it is in means receiving, out means sending out. Slave is going to send the data, correct? Slave is going to send the data, master is going to receive. That is called MISO. Note down this, okay? Then SS is nothing but ground, correct? That is slave select. It is called slave select. It's not ground, it's called slave select. This is apart from ground signals. There will be called ground. So generally there will be 5 wires. 4 wires are there. SS means slave select. Why? Because as in the SPI, you can have one master, multiple slaves. Correct? You can see here, there's one master, there are 2 slaves, slave 1 and slave 2. That means there are 2 devices. This is one ECU. This is, so I say ECU 1, this is ECU 2, this is called ECU 3. In this, ECU 1 is the master and ECU 2 and 3 are slaves. Here, I say ECU 1 and ECU 2. Not necessarily always have 3. You can connect two devices also. You can connect more devices also, correct? More than one device, which is not possible in RS-232. RS-232 only you have two devices at a time. You cannot connect more than two. So one is transmit, other one is receive, ground, correct? This is say ECU1 and this is ECU2. Okay, so only two devices. You cannot connect third device like this. Not allowed. One-to-one communication. Only two devices are possible. But in case of SPI, you can connect more slaves also. Okay. Now if I select more slaves, how many are possible? Two slaves are possible. In case of serial peripheral, you can connect more than two slaves. Okay. So now I wanted to transmit the data 10101101. Correct? This data to which device? This data is in the master. Correct? And I wanted to send it to this slave 1. Then what I have to do is, you can see here the slave device is selected. There's a pin called SS, which is called CS1 chip select, which is connected to CS, which is nothing but SS, slave select. So what I connect to this so that data from this will go to this device only. Now that means generally this will be 0 volts. If I select 5 volts, which is nothing but 0 or 1, then whatever the data this device alone will read. Please see that the MISO and MOSO are connected parallelly. Correct? But the chip select alone is separate. You can see the chip select alone is correct. So the chip select is separate. So this one goes to first device, this one goes to second device. But that means if this device is 0 and this device is 1, if I send some data in this or in this, so that will go only to this device. If I wanted to send that same thing to this, what I have to do? Sorry, to come here. So if I make this equal to 1, this equal to 0, data will go here. Instead of that, if I make this equal to 0 and this equal to 1, data will come to this. That's why for the chip select device is selected. Okay. So you can, so this high speed communication. Another thing what I want to show is, please see that this is data. So the data, so this is called clock. The data is first sent, correct? This is the data duration. For example, this is 1. First bit is 1. So you can see that this voltage is high. This is 5 volts. Which pin? MISO pin. MISO pin equal to 5 volt during this period. And even though data is available, the slave will not read the data like RS-232. It will wait for this clock. You can see that this is the clock. I have also shown here, there's one arrow. This is first clock. The first clock, second clock, third clock, fourth clock, fifth clock, sixth clock, seventh clock. This is the eighth clock. Okay. Now data is high. In case of RS-232, I told you the if I transmitting 1 kb, 1 kb per second. Okay. So kbps. Since we are talking serial communication, it is called as kbps. Let me write clearly. If I am transmitting 1 kbps, okay, that means 1000 bits per second. One data bit duration. Note down, these are important. Bit duration is nothing but 1 divided by 1000 seconds is nothing but 1 millisecond. So the data will be high for 1 millisecond. In case RS-232, the receiver sees this data and RX pin, immediately it will note down that bit equal to 1. That's how it is noted. But in synchronous SPI, which is serial, even though data is available, the slave will not read it. The slave will wait. Wait for what? This clock. You can see here there's an arrow. right? They call racing edge of the clock. During the racing edge only, it will read the data, not for the entire duration like RS-232. So during the racing edge of the clock, okay, so it sees what data, it is 1. Okay, if you don't supply this one, the data will not be read by the receiver. If you don't supply this clock in SPI or synchronous communication, the slave will not read the data, it will wait. Even though you have presented data, it won't read. Next, what happened? But in the next data, you know that period is this, right? This is next period, second bit. Again, that bit also 1 only, master is sending. Now, the slave will read only here, this only when raising it. During the time, this has to be high. Like that, for each data, this is the third bit. Third bit, the data becomes 0. You can see that the dotted line, this dotted line shows, see here, that time, this data, whatever data is there on the MOSO, that will be read as a data. So that's why it is called synchronous. This is a fail-proof communication, right? So only what is the disadvantage? Apart from the data, you need to supply clock also, right? And apart from that, there are 2 lines, one for transmission from master to slave, other one to slave to master, then clock, then chip select, then ground. You need 5 wires approximately for serial, but it enables communication between electronic that support clocked serial streaming. It is called clocked serial streaming. Okay. Now another thing is, see here, this is master is transmitting data to the slave, right? The master is transmitting data to slave to the green wire. This data. Now slave is replying. Slave can also give reply. Please note that slave can transmit data in SPI also. Okay. Then what will happen? That data will come from MISO pin only. This is the slave reply. That is come to MISO. Master is going to read. MI means master is input, slave is output. The data is sent back. So then this is how it works. So SPA is a master slave method for communication. They enable high speed data. Here it can transmit in the order of megabits per second, 5, 10, 20 also. You have to see the data sheet. Okay. So in the RS-232, it is in kilobits, 20 kilobits or 36. That is what's very, very slow, dead slow. Then as approach to 2-wire communication, USART. The USART is nothing but universal asynchronous receiver transmitter. That is called USART. Asynchronous, there already shown asynchronous communication, RS-232. Correct? The SPA must use 4 wires. In case of RS-232, only 2 wires are transmit, receiver, and correct? Transmit and receive plus ground. In this case, you need 4 wires. That means, in fact, 5 wires are needed, including chip select. This is 5 wires. It supports multiple slave devices. Correct? The master and 2 slaves. If need, you can expand even 4 slaves also by having appropriate arrangement. In SPA, so key points note down. It is a synchronous communication SPA, serial peripheral interface called synchronous communication. SPA is simple protocol with little overhead. You don't need handshaking signal. Please note here. Correct? In the SPA, you don't see RTS, CTS, hardware handshaking. We have 25 pins, correct? All those things are not needed, because that is taken care by the clock. Okay. So it supports full duplex communication. That means the master can send data to slave, slave can give reply to master. That is called duplex communication. SPA communication does not have mean for acknowledgement of flow control, all those things. Like flow control, nothing but CTS, RTS, correct? Send, please get ready, correct? That kind of, this is not, the flow control is not there. See, flow control has advantages and disadvantages. We have to see which is better, okay, depending on the situation. Have you taken the notes, key points?
Yes, sir.
Yes, sir.
Okay, now we will talk about, we saw two types of serial communication. One is asynchronous communication, otherwise a synchronous communication. Asynchronous RS-232, synchronous is SPA. What is the advantage of SPA? It is complete, it has a complete flexibility for the bit transferred, not limited to 8 bits. Here we shown that the data here transmit is, generally we transmit a byte by byte, correct? Byte by byte. Sometimes if you want to transmit 64 bits, between there are two CPU. I told you, this is used between two CPU, CPU1 and CPU2. In a motherboard, you can have two CPU. In your embedded controller, vehicle controller, you can have two CPU, because lot of computation means you may use two CPU. That means those two CPUs can generally, this SPE used to do for communicating between two CPUs, not outside equipment, but you can use it between two CPU, clock, MISO, MOSI, correct, and chip select, SS, correct. These are two CPUs are there. If this is a 64-bit CPU, this also 64-bit CPU like i7 processor, right? At a time, you will be transmitting not this one up to 64-bit. Yeah, complete information can be more than 68 bits, not byte by byte. So the serial peripheral interface supports n number of bits can be transmitted. Only thing is, if you have the more number of bits, then more number of clocks are, equal number of clocks has to be there. That's what we are trying to say. So it is not limited by transmission like byte by byte transmission. Serial communication, data is transmitted as a 1 byte with a start signal, stop signal, parity signal with 8 or 7-bit data. That is byte by byte. Then you will send. But in SPA, it need not be byte. It can be 16-bit or 32-bit or 60. One information itself say a big number. Right? It can be longer. This one, that's what is possible. But accordingly, number of clock also will be there. Correct? So I say that this is 32-bit. Correct? My data is something like this. Right? So this is bit 0. This is bit 31. This is 31-bit data is there. Correct? For that, you give 32 clocks. So 32 clocks also to synchronize. So I can send longer than anything 8. That's what I want to say. Okay. It more than else. It is very simple hardware interfacing. Okay. It has only 4 wires. Correct. MISO, MOSI, then clock, synchronous clock, and chip select and ground. Not limited to any maximum speed. Correct. As I told you, it can be 10 megabits, 15, 20, depending upon the CPU. Correct. Depending on particular design hardware, it can vary. It is faster than asynchronous. For asynchronous, I am talking RS-232. What is this one? 19.6 kbps or 36 something was the maximum was 36. We saw yesterday, noted, correct? So here you can go to megabits, Mbps also possible, 10, 20, 30 also, correct? Even 100 megabits also possible if the high-speed process. It supports multiple slaves. As I told you, 2, 3, 4 slaves also, one master. Right? Here we have shown 2 slaves, one master with 2 slaves. It can go more also. Support, and it supports full duplex communication. Master can send data, slave will receive. Slave can say reply, master will receive. So they call full duplex communication. It is having one unique bus signal per device called a chip select, so that any slave can be selected. Correct? If we have 2 slaves, we saw that we have 2 slaves here. Right? So by making this pin equal to 5, other one logic I which is of 5 volts, and making this equal to this pin equal to 0, nothing but 0 volts, this device is disabled. The data will be transmitted to the first slave. By making this pin equal to 1 or 5 volts and making this pin equal to 0 or 0 volts, this device is this one, data can be transmitted like this. So master can decide to which device you can send data. Correct? That is the advantage. More devices can connect it, and anytime master can decide data can be sent to any slave devices, which is not possible in case of RS-2. Only 2 devices are possible. Okay. No arbitration fail modes are there. This we will see when we talk about arbitration. Just note down, no arbitration means if there are 2 slaves, correct? if two slaves wanted to send the reply, correct? Say master is sending data, slave is giving reply after some time, correct? So in this case, we have selected the chip one only, correct? Chip 2 cannot decide, slave 2 cannot respond at all, correct? There's no question of competing. When two people are coming, we need arbitration, correct? When, for example, a musical chair, correct? You know the musical chair? One chair will be there where people will be circling, running around that. When some music stops, somebody will sit. Finally, two person will be there. Sometimes you will see that both the person will try to sit in the same chair. Then they fight with each other. I came for this one. Right? Then what will there? A judge will be there, who is called arbiter. He will say that no, I saw that person. Arbiter, they call arbitration. You go to court. Court is nothing but arbitration only. Correct? You say this is my house. Somebody said that this is my house. Two people are fighting for same this one. Similarly, here that will not happen. Why? The master clearly says, if the master want to send the data to slave 1, it will select the chip select 1. This is 1. This is 0. Automatically, this fellow cannot receive data, cannot give reply. This is reply from the slave. Master is asking some data, right? By sending this command, and slave is replying this. Master is sending this. Slave to this is from slave 1. Correct? Slave 2 cannot respond because he has been not selected by CPU at all. CPU disabled. By making chip select equal 0, that means this fellow permanently disconnected. Electrically connected, but it's not allowed. So the communication happened between these two. So there's no arbitration. Arbitration happen only both these slaves are trying to reply. So the data is from slave data. Correct? This can be given only by because clearly you have selected slave 1. Instead of that, you can say that if master select this equal to 1, this equal 0, that means this fellow, the data from the master will go to slave 1, correct? And the data from the slave will come to master. This fellow cannot respond. So this is what arbitration. There is no requirement of arbitration at all because you are clearly selecting for which device data should go by selecting CS signal, chip select signal. Okay. So there's no transceiver needed. As I told you, the transceiver means in RS-232 communication, again, note down, I have a CPU 1 or your ECU 1, your vehicle controller, and you have ECU 2, correct? This is ABS, this is EMS, engine management system. There's a CPU, correct? So from CPU, data will come to trans receiver IC. Trans receiver IC. Similarly, from here also, there will be one trans receiver IC. Okay. Here, data will be transmitted like this only. This is 1, this is 0, this is 1, 1, 0, 0, 1, 0. Correct? This is 1, 0, 8-bit data. This is 0 volts, 5 volts. Here, into plus 12 volts and minus 12 volts. Correct? That is the job of the transceiver IC. Now it goes to the receiver transceiver. Plus 12 volt, minus 12 be converted to 0 to 5 volts. Then it go to CPU. Sorry. In case of this one, the transceiver IC is needed in case of RS-232. Why? The data is transmitted plus or minus 12 volts. Logic high is transmitted as minus 12 volts. Yesterday we saw logic 0 is transmitted as plus 12 volts. Yesterday we saw no, but it is who is going to do that? That is transceiver IC. Converting this is 0 volts, 5 volts will be converted to plus minus 12 plus 12. Who is going to transceiver IC? Please know that it will be inside your computer. Don't worry, everything is inside. In the motherboard, wherever the port is there, RS-232 is there. But you need this is called as transceiver level shifter. Other name is called level shifter. What it shifts? The voltage level 0 volts into converted to plus 12 volts, plus 5 volts is converted to minus 12. Correct? But inside the CPU, you need 0 volts or 5 volts only. All digital ICs. Please note down all digital ICs which include microprocessor. Correct? MUP, memory ICs, And many of the, whatever inside your computer, many of the ICs are detail ICs. They work with 0 volts and plus 5 volts only, which is called the TTL level or level signals. TTL level signals. All the computers, your laptop, cell phone, any digital device, if you say that inside that, the binary data is meant plus 5 volts only. But when you want to transmit to RS-232 communication, the voltage should be shifted to plus minus 12 and plus 12. Correct? That is done by transceiver. But in case of this SPA, I told you, it is generally used within the computer itself. Correct? Between two CPUs, CPU1, CPU2, CPU3, inside one motherboard or in your embedded controller, vehicle controller. So they will be connected. So that means data is transmitted within few feet, not even a feet, few inches, correct, within the motherboard. So the voltage will not be shifted, it will be transmitted a 5 volt signal only. There's no transceiver is not needed. That's what we are training, correct? So the true not is what, because we are going to set 0 volts or 5 volts, which represent the logic 0 and logic 1, binary data. Okay, this is advantages. Note down these advantages. What is disadvantage? It requires more pins in a package, right? Which we say that you need 4 pins. This one you need RX, TX and RX only. Of course, ground is there. In this case, what you need? MISO, MOSI, and clock, and SS and ground. These are SPA. SPA requires more number of wires, more number of pins. Correct? This is RS-232. So this is disadvantage. More wires are needed. Okay. It does not support hard swapping. Okay. Just note down. It is a little more the hard swapping. When device is on, you cannot remove the wire. So if you are connected two devices, right, to SPA, you cannot remove this, disconnect the wire while both are on. Hard swapping, when device is on, when circuit is on, you cannot remove the connection. If you do that, sometimes the circuit can fail. Okay, so there is a hard swapping, it is not allowed. Okay, it's suppose only one master at a time. We know that there's one. While designing circuit, please note that always this will be the master. These two are slaves only. Master will ask data, slave will send the data back. Master will ask the slave, slave will send data.
Sir, one doubt, sir.
Yeah, yes, please.
Sir, for hot swapping, can you tell me one example, sir?
Hot swapping, for example, telephone exchange, or if you go to, when system is on, you can remove the board. There is a big system, correct? There, go to telephone exchange, correct?
Yes, sir.
There will be multiple boards will be there. One board failed, correct? So you cannot switch out entire telephone exchange because people are talking. You want to do service. You cannot never switch off the telephone exchange because there are 10,000 lines, correct? There may be. So at that time, the circuit is designed such that even without switching on main power, you can pull out the which board failed, that you can pull it out and put the new board.
Understood, sir. Okay.
Okay. While doing that, the circuit should not fail. The board what you are inserting the new board, that should not fail. Generally, what we say, when you want to open the computer, what they say? First, switch off the power. While computer is on, inside board you got hard disk, no? You can open your CPU if you know there are memory chips, correct? SIMs, all those things. You should not remove any of the IC inside your computer when power is on. Not only you get shocked. If you remove it, there are chances that the IC, the circuit can fail. Most of devices are not hot swappable.
Understood, sir.
Switch off the power, then only
RAM
physically remove.
Yes.
Okay. So
Okay, sir.
no error checking is not there. Like this is no parity check. We saw the parity bit yesterday. Correct? That is not there. What I was saying, even the error happens, receiver doesn't know. But generally doesn't happen because everything is put inside one motherboard, very short distance transmission. Already computer is shielded. Your EC is shielded with metal box, EMI, everything. So SPA, because it's generally used between very short, few feet or within a meter, correct? But to this one. So error check is not there. SPA usually requires additional lines called chip select IC, correct? Like this, these are the disadvantages. With this, we stop. Now we'll go to, this is just introduction for last 2-3 days around this one, I introduced what is communication, wired communication, the basics of the parallel communication, serial communication, and in serial communication, asynchronous RS-232, which was used in computer for more than 100 years, which just vanished because of the USB port, correct? In computers. Before the USB came, every system had only RS-232 or parallel, IEEE, GPIB only. All the computers up to year 2000. USB came only 20-25 years before. Okay, USB also serial communication only, that is used in computer, but not in this one. Now we'll go to next one. The main thing, our interest, what we are going to see is lectures. This is what we have imparted for you. But the other one also important. I am not saying important. In the exam, I will ask question for RS-232, SPA, and as well as the body parallel, all these things. But as per vehicle is concerned, when you talk, your most important thing is CAN bus. Visible?
Yes, sir.
Yes, sir.
Already, when the beginning is I told what are the in-vehicle communication, there are 4 types of communication, wired communication. Very popular is important is CAN bus. Now everything is important. Then LIN bus, then I saw MOST bus and flux ray. These are the wired communication used in automobiles. We will start with first about the CAN bus. Okay, what is a CAN bus?
Sir, before starting,
CAN bus.
had one.
CAN bus is the short name for controller area network. CAN. That is what we say CAN. Again, it is a wired bus. It was developed by Robert Bosch company for automotive application, specifically for automotive, because it's automobile company suppliers. ECU supply, starter motor, anything related, electrical related is supplied by Bosch. All European car companies are buying, American company, Indian companies are buying, your company may be buying from Bosch, starting from spark plug, current distributor, high tension wires, ECUs, even anything, right? Injectors, injector control my vehicle. Okay. So then it was introduced 1980s and released to public after 6 years. Before that, your proprietary item, nobody can use except the Bosch in the electronic hardware. In 1986, they allowed to popularize, they allowed others to also use, but of course, you may have to pay some royalty. Now that also not there. Okay. To my knowledge, you need to check if you're going to design. CAN bus is a serial multi-master, multicast protocol, no doubt. Just now I told you SPA is a single master, multiple slaves. Okay. In case of RS-232, there's no master slave because whomever transmits is a master, other fellow is receiver. Receiver is called a slave. So in RS-232, there are 2 devices. Whenever data is sent from device A, it is called master. Device B is called slave. If device B sends data, device A receives, device B become a master, and so that is what RS-232. Only 2 you can connect more. In case of CAN bus, you can connect multiple devices, just like your SPI. 1, 2, 3, 4, even up to 256 devices you can connect in CAN bus. And the other main advantage between SPA and CAN bus is any device connected in CAN bus can become master at any time. Okay. If I have, so for example, here I'm showing 3 devices. Please see here. This is my CAN bus. CAN bus nothing but 2 wires. Like RX and TX, here there are CAN H and CAN L. There are 2 wires. You can see that there are 2 wires running. Okay, this I can say CAN H and CAN L. L means low, H means high. 2 wires. There are these wires is running, can be up to 2-3 meter, whatever length you want. Then from there you can connect any device, for example, engine ECU, EMS. Correct? This is ABS. This is steering controller, SC. These are ECU. Correct? The whole thing is. So each one is called CAN node. If I connect any ECU to CAN bus, that ECU become CAN node. So I have 3 nodes. So 3 can node 1, node 2, node 3 like that. Okay. Now, since like this, I can connect up to 256 devices. Even more also possible, we can see, but then we never going to connect like this. Many, even I told you, advanced vehicle may have 10 or 20 ECUs or 30 ECUs, not more than that. Many times it end up with 2 or 4 or 6, most of the vehicles, except high-end vehicles. Okay. So now the CAN bus is a and now I say the CAN node 1, CAN node 2, this one. If this fellow is transmitting data, these are receivers, RX, like I say RX1, RX2. So transmitting. So at that time, this is called as master. This EC will become called bus master. Right? It is called, correct name is called bus master. Okay. During them, these are slaves. Right? Slave 1, slave 2, something like that. Okay. Now, once the data is transmitted by, say for example, this is my ABS. You applied brake pedal, correct? Immediately it says sends a data to engine management. This is EMS. Reduce fuel. Correct? Reduce fuel. That means they have to decelerate. So it sends a command to this fellow requesting. That time this is master, this is slaves. Correct? Please note that same data is going to the steering controller SS, steering controller SC also. Right? But this fellow will not respond. He knows that the data from ABS is to EMS only. I'm going to explain how it is. Correct? So the data sent by the ABS to reduce the engine speed or reduce the fuel is meant for this one. This fellow will immediately respond by controlling this one. Okay. But then, even though the data is received by SC, steering control, it knows that this command is not meant for, he won't respond. He will receive, he will listen, keep quiet. For example, I am asking Vijay Raj, I want something. Correct? There are 24 students. Others will not respond because I am master, bus master. Now I am asking. Correct? So I am asking him and he will respond. Yes, sir, please tell me what you want. Others should not respond. Because I say, students, can you respond? Then all 24 will respond. But I am specifically saying the specific name. Correct? So others should not. So if the engine ABS sends a command, reduce engine fuel. That means that command itself very clear. Reduce engine means then only EMS can do. Okay? Others will keep quiet. But everybody is listening. So all the devices called listen. Now the engine, the EMS has reduced the fuel. Correct? It may give a reply. Yes, I have reduced fuel. Correct? It can give a reply. Okay? It sends a data. 1 minute. So it gives a reply. Right? So please see the same reply goes to all devices. Now this fellow become master. Whomever is sending data, he will call a master. Now he will become a slave. Which one? ABS will become a slave. The steering control also will become slave. The data is coming and going through bus, common bus, right? Whomever in the bus will receive data. But who has to respond? Only engine ECU. Yes, I received. Otherwise, at least you will know. So this is how it works. Okay. This is called as master-slave control. But main advantage CAN bus over the SPA is, in SPA, you have only one master. Predefined. You cannot change it. By designing circuit itself, others will be master. Slaves can reply. Correct? But slave cannot send data on their own. Correct? Did you see that? There's a chip select is there. Chip select device. From master, chip select goes to each device. This is slave 1, slave 2. This is master. I am talking SCA. SPA. Serial period. So, even though this one, anytime master will ask data, slave will send reply. Master will send ask for data, slave will send this. But slave cannot send anything on his own. That is the drawback of SPA, another thing. Correct? So bus master decides whenever he wants data, he will ask data, this fellow can reply. That is called master slave response. Slave can never command. Correct? So only master can give, ask data, slave will give. Whatever master says, that you have to do. He asks data, you have to give. You cannot go and say that I have data. Not allowed, master slave. But in case of CAN bus, That is not good for every possible communication. In case of a vehicle control, correct? So when you apply brake, even though engine is running separate controller, this one, the ABS ECU become a master because it has to tell the engine ECU stop engine or reduce the fuel, decelerate. I am going to apply brake. So that time this has to become master, others should become slaves. When engine is doing something, correct, or steering is doing, for example, steering control, you are taking a sharp turn, correct? When you take sharp turn, what you do? Suppose you are going a highway, correct? It bends. Okay, you are going 70 km speed, your vehicle. When you go, what you do?
Reduce the
Same,
speed.
what you do?
Reduce the speed.
You reduce the speed. Then, how will you reduce the speed?
Applying the brakes or releasing the throttle.
You
Releasing
release
the
throttle, simultaneously apply brake also. Okay,
Yeah.
but you are controlling here. But you are turning the steering wheel. If it is autonomous vehicle, what will happen? Who is going to steer the vehicle? Steering controller. Already we talked, correct?
It is steering
Steering
control.
control. Steering control based on the curvature, using the camera, correct? The data has come the vehicle controller. Steering control going to steer the vehicle. You should not just like the village steer. As a human, what you do? You will steer, simultaneously reduce the engine fuel, throttle, and all apply brake. All three you will do simultaneously. Correct? Then who is the master? In this case, in autonomous vehicle, you have 3 ECU. Which will become master?
steering control.
Steering will become master. Correct? Brake and engine will become slaves. Okay? They both will respond. So now, if you are when applying brake, ABS is master, other two are slaves. So anytime, any device ECU can become a master. So that means you cannot use SPI for controlling your connecting different parts of your vehicle, autonomous vehicle. That's why the boss invented CAN bus. Okay. Okay. In CAN bus, any device can become master anytime. But one fellow become master, others automatically become slave. It is compulsory. Correct? Then suppose engine, you are applying brake, you are steering, you are accelerating. All three you are doing simultaneously by somehow. It is impossible. Somehow you are doing all three. You are turning, applying brake, and also accelerating. Correct? Which one? What will happen if you do all those things manual control? What will happen to your vehicle or to you?
While controlling all together, you mean, sir?
I am applying acceleration. I am also applying there's some brake. I am also steering. Vehicle will topple. You will meet an accident. Right?
So maybe based on the logic, it will take brake data and it will ignore.
Yeah, you are correct. Satish, you are 10%. That's what it has to do. Correct? So now, no, why I'm coming there means I told you